In this episode, we will be doing 19 groups of descendants instead of 10 because of the uneven amounts of plants and animals. The first species descendants we'll be looking into are from Calidae kaput, the first generation being made up of Major kaput and Brevior kaput. Major kaput, who has to deal with the extreme predators with a giant weak point, has paler skin to better match the color of the cup's white skies. Major also will stay in the air for longer portions of time. Major kaput's mouth protrudes more than Calidae's did. Major kaput not only has stronger arms, but also longer arms. Brevior kaput. Brevior has shorter arms. Brevior also has a paler body, but only the front, back, and underside. The top is still a vivid blue. Brevior can inflate and take flight faster than Major or Calidae kaput. The membrane used for flight is also stronger. The second generation is made up of Carotidus kaput, Dentum kaput, and Codex kaput. Carotidus kaput has white skin on its very underside, but the rest is orange to better blend in with the Folium it lives with now. Because now Carotidus spends more of its time on the ground, Carotidus is an omnivore, now eating fallen fruit and meat from any prey it can catch. Carotidus now mostly hunts on or just above the ground. Although this generally reduces their chances at a successful hunt, it also reduces the chances of them getting hurt during an attack. And to help it find prey, Carotidus has 2 bigger eyes and the other 4 remain small. The teeth have adapted to eating a larger variety of food, and the claws have spikes to improve the damage and grip of the claws. Carotidus also has 2 bones sticking out of its body. These help protect the animal in case of an attack, a little bit. Carotidus also has ovivivorous tendencies, eating the eggs of other kaputs who nest in similar locations, now being cliffs and more mountainous region. The other Calidae in question includes Dentum kaput, who has even longer arms, paler skin, and the Veritarp is a darker orange. Dentum has changed their hunting habits as well. Now using their superior intellect, they will wait in the skies and stalk prey and determine how strong it is. If the prey, which can be a variety of things, is deemed to be safe to attack, they will float down behind the prey and begin slashing at it with its claws. If/when the prey falls to the ground, they will fully deflate and use their far bigger fangs to bite down on the neck, or the closest thing to the neck that a prey has. They also will remain in the air for longer periods of time. Next in this generation is Codex kaput, who no longer has arms. And despite losing its arms, it has gotten heavier with dense bone. These bones not only help crush prey in an attempt to instantly kill prey, but they also protect Codex from damage on impact. These do come with the downside of taking more effort to take flight. This would eventually become their major downfall. Because now if the prey survives the hit or Codex misses, it will take a good 10 to 13 seconds for Codex to take flight, another 4 to 6 to get out of reach. And that's assuming the animal is not blocking it from inflating or moving up, or hasn't cut open the membrane. This combined with the blue and white coloration on the orange Folium makes Codex, if not in the sky, an easy prey item, especially without arms for Codex to defend itself. Codex also still nested on the ground, where many animals could at best crush its eggs, or at worst, eat it and its eggs, all of which leading Codex to go extinct. The final descendant, and the only in Generation 3, is Dolor kaput. Dolor has massive arms with giant razor-sharp claws. Dolor is now capable of staying in the skies for over a day straight, even sleeping mid-air. Dolor has continued to refine its hunting strategy, and not only for hunting, but just in general, Dolor is far smarter. The major problem Calidae kaput had when joining the 60s Cup is that there were more than 2 animals that were able to kill it, and now the biggest problem Dolor faces is Titan Aulus, the Penna army descendant. Although the helium bubble flight has advantages over powered flight, like less energy cost, and you don't need to dedicate any limbs to flight, there are 2 major downsides. One is speed. While Titan Aulus can outpace any other flying and walking animal, Dolor is quite slow and needs time to get to its prey. The other downside is that you have a giant weak point to defend your entire life, and alas would easily be able to kill Dolor. Dolor avoids this by being diurnal, but this means that its prey can see it, and because of this, Dolor is extremely picky about its prey. It will only attack blind animals, and anything Dolor even thinks it's remotely too big, it will not be touched. Dolor actually gives a premature warning to any animal that can see. Above the claws is bright yellow skin, warning animals with sight to get out of the way. Dolor also has venom in its claws, but the left claw and right claw have two different venoms. The left claw, our right, has an anticoagulant. This prevents blood from clotting and causes the animal to bleed to death if not close. The right claw, our left, has a paralyzing venom, stopping the animal from moving after about 35 to 40 seconds. Dolor is strong enough to be able to carry many of its prey to its nest, made from anything Dolor can get its claws on. Bones, dried stems, skins, and any other relatively durable item Dolor comes across. Unlike all other descendants, Dolor will take care of its children. After the female lays the eggs in the nest, she will leave and the male will look after the children for the first few weeks, finding food for them. After a few weeks, the babies begin to leave their nest on their own, and the male just lets them, although any still in the nest after 4 or so weeks get picked up and forcefully thrown out, or just eaten by the male. The next species we'll be talking about is Sylvosis lingua, with the first generation being made up of Haematus lingua, Verminculus, Photolingua, Laxus lingua, and Ligo lingua. Haematus lingua. Haematus has moved far lower in the cup, where eventually Coryza and Dwilique would come to live. But even before them, few animals would come to the tundra for a variety of reasons. Some came on purpose, many not. And these animals act as an opportunity for Haematus. Instead of having any hairs on its tongue, at the end is a venomous barb. The venom Haematus has is, although weak, could still get the job done against an already weak animal. The barb itself has reverse spines, making it hard for prey to get away. After catching prey, Haematus will carry the carcass on top of the shell and begin slowly eating away at the body, often taking weeks. Haematus is also bigger than Sylvosis was. Haematus does have many of its own downsides though, one being a lack of abundant prey. Coryza and Dwilique would not come to the tundra for tens of thousands of years, and catching the available prey was hard. Some prey was fine, some too large to care about Haematus, and some could get captured and end up getting away, which often means for Haematus getting its tongue ripped out. These, along with Haematus's poor ability to even sense prey in the first place, has caused Haematus's extinction. Verminculus. Verminculus has undergone an extreme change in their lives. They have undergone an extreme form of neoteny, never becoming adults and reproducing in their juvenile bodies. Verminculus has moved far lower in the cup, living in the more common plains or steppe. Verminculus luckily doesn't have to compete with the later Caerulum and Luteus Fisters, who yet don't exist. To defend themselves, Verminculus can still produce their concrete-like substance, now taking longer to dry. It's used to build basic nests with many holes in them. And now with the warmer climate and more food and water, Verminculus is much bigger than the previous larva. Photolingua. Photolingua is very similar to Sylvosis, although now with a new way of obtaining food. Photolingua uses photosynthesis, harboring photogears to do so, unlike the false plants who use brine cells. And although that means Photolingua doesn't get the protective benefit of being a salt machine, it living in the tundra basically prevents all predation. Photolingua can still filter dust, just not as much. Dust still makes up about 60% of the energy it gets. Photolingua also has a shorter tongue and a lighter colored shell. Laxus lingua. Laxus is quite different. Instead of the normal tongue of Sylvosis, Laxus has a broad tongue capable of the same dust collection as before, while also producing and storing more heat. Laxus also grows in small groups between 4 to 6. Laxus also changed the way they grow. Instead of just attaching to the ground with a suction cup, first they dig a small hole and build the shell over it like a dome. This helps insulate heat as well as provide space for them to grow. A major advantage to growing in groups is that you will almost always have a mate, and since groups are made up of unrelated larvae, incest isn't too much of a problem. Or if a predator is about, they might eat your neighbor instead of you. Laxus would find great success while other descendants either continued up or fell back down the cup. Laxus stayed exactly where it is, staying with little competition. And finally for this generation, Ligo Lingua. Ligo lives at the same level and further up the cup, now being Laxus's form of competition. And just like Laxus, Ligo lives in groups. These groups are always 4 members large and face opposite sides. Ligo is not much different than Sylvosis, but does mark an important evolutionary line. The second generation is made up of Liquidum vermin, Dens vermin, Fictus Arbor, Fictus Runco, Titanus Fictor, Seta Lingua, and Fortis Colonia. Liquidum vermin. Liquidum is now semi-aquatic, spending much of its time in the soda, even having appropriate counter-shading that even top-tier predators like Cava Facies lack. Liquidum has 4 teeth it uses to eat plants like homunculus at the bottom of lakes, rivers, and ponds. Liquidum has not just a paddle-like tail for movement, but also a stingray-like fin going down the length of its body. These two are never used in unison with each other. The long fin is used for day-to-day movement. It's slower, but uses less energy, and the body doesn't move, so the head stays still. If Liquidum is being pursued by a predator, it will swim more side to side, being much faster, but it takes much more energy, and the head moves quite a bit. Liquidum only uses this when it's being pursued by a predator. Liquidum vermin is also quite a bit bigger than its ancestral larva. Dens vermin, or Dermin as I'll call them, also feature teeth, but only 2. Dermin's tongue has slightly reduced in size and has no extrusions on it. Dermin is also an herbivore, eating small fruits and lower, softer vegetation. Dermin is a bit bigger than its ancestors. Dermin's skin is tanner to help camouflage against the Folium. The next 3 animals are very similar in their lifestyle, only with 1 or so major differences, but we will start with Fictus Arbor, who, like the next 2, have fully migrated to using photosynthesis to survive. Fictus Arbor, or Farbor, is far larger and has many more hairs. Farbor now, in the second generation, lives with Coryza and Dwilique, but more importantly it lives with the bulbous Folium descendant Frigid Frons. Although Farbor actually outcompetes Frigid Frons, thanks mostly to the shell of Farbor keeping it warm, while Frigid Frons has to cope with the cold. Not saying Frigid Frons doesn't have its own lands. Farbor grows in large forests and helps to provide shelter for Dwilique and Coryza from both the cold, with the body heat of Farbor warming the ambient temperature a tiny bit, and blocking the wind. And Farbor helps against a problem we will talk about later. Farbor and its 2 other relatives can still process dust, just not nearly as much as before. Fictus Runco. Runco is actually smaller than previously, but comes with the advantage of being capable of growing on high rocks or, more importantly, on other linguas. To help further with surviving in the tundra as a small lingua, Runco can change the angles due to the base of the shell not fully solidifying. This allows Runco to a degree to avoid shadows and continue photosynthesizing. The last of this trio is Titanus Fictor. Fictor is more interesting of the 3. Fictor has a specialized hair with barbs on the end of it that they use, especially while they're in their larval stage, to kill other barnacles, even if it's of its own species. This is so that when they become adults, they get all the nutrients, water, and light to themselves. Fictor, even as an adult, has this hair to kill Fictus Runco. Being first has its own slew of benefits. Mostly that being the first means that any others that come to grow can't reach your one soft spot and have to work around you, therefore they struggle more. At least with the idea that they have to share, and at worst having the constant shadow of you on them. Fictor is the third largest descendant from Zilvosis, but takes the longest to grow. An entire decade. Fictor is also yet another example of getting bigger and filtering dust correlating with aggression. Next is Seta Lingua, who now lives in bigger colonies. The colonies can be anywhere between 6 to 10 members. Instead of having mostly segregated shells, Seta has one large shell everyone shares. This shell has many funnels sticking out for each member. These funnels allow them to stick out their tongues to collect dust more protected. And with a more upper lifestyle, they might just collect more dust than what they know what to do with. Other terrestrial filter feeders either just stop collecting dust or throw dust out. But Seta has a hexagonal structure in the center of the shell. This structure holds pre-digested dust for future use when there's less food. Seta's tongue is thinner but has more hairs on it. And finally for the second generation is Fortis Colonia. Colonia individuals are far bigger than the other barnacles. Fortis Colonia also live in extremely high portions of the cup, living almost on the lip of the cup itself, where it's the coldest. Colonia has two combatants against the cold, one being a darker shell absorbing more heat, but another is living in enormous colonies. These colonies are forever growing, and when old individuals die, new larvae grow their shells on top of the old ones and cut holes through it to allow movement and growth. This colony growth leads to not only colonies that can last centuries before dying off, Colonia, counting the whole colony, can be bigger than any other organism. Even bigger than the previously bigger than any other organism title holder, Gigant's hive mind. Although if you count only individuals, then neither are the largest. There are only two ways that a colony dies, one being rare but can happen to any animal in the cup, a prion disease, spreading out and killing everyone. Or the far more common colony killer, gravity. As larvae hollow out the old shells and form new ones, eventually, in time, clumps of individuals grow in a bad direction, and over the years they keep going, and eventually the branch will break off. Sometimes this can be a good thing, both groups can survive and there's now two colonies that will eventually merge into one big one. But other times, the broken branch causes snow and winds to enter, both freezing the adults and especially larvae. In some instances, the base of a branch shatters and the branch falls onto the colony, crushing individuals and shattering years' worth of development. This also means that there are plenty of empty colony husks shattering with nothing to remove them. These can be useful for larvae starting their own colony, but also for another species we'll talk about later. Larvae can start their own colony in two ways, one being two gametes meet outside a colony and burrow under the snow and ice to find a more suitable spot, or an already developed group of larvae leaving its colony and digging through the snow to find a good spot. Although the gamete start is more dangerous in the beginning with a cool 87% chance of death by freezing, but if the gametes survive, they actually have a better chance of starting a healthy colony than the developed group. Mostly because while colonies do release gametes outside, they also do so inside the colony shell, basically meaning massive incest after the first few years. And although Colonia has special genes preventing most mutations because of this, it still helps not to be inbred when starting a colony. And the developed group still has a 62% chance of freezing to death. The third generation is made up of Praegrandis bula and Plectrum vermin. Praegrandis bula. Praegrandis is far larger than before, now being the second largest descendant of Zilvosis, and the largest if you don't add the colonial adaptation of Colonia. Praegrandis has a stronger bite to defend itself against the many aquatic predators the cup has to offer. Many other aquatic species obtain this size by being the predominant danger, or being a very dangerous target to attack in the case of Shredder and Gigant's dens. But Praegrandis is mostly herbivorous, eating the living homunculus at the bottom of lakes and rivers. If the opportunity presents itself without any problems, then Praegrandis will scavenge any carcass it smells. But Praegrandis is rarely aggressive, only really being aggressive when protecting young or fighting back against a predator. But due to its size, Praegrandis doesn't have to worry all too much. It's mostly a more desperate Cava Facies or a more feisty Cnetantus crocodilius. Cnetantus bulticus's jaw makes hunting large, flexible prey like Praegrandis a risk of breaking its jaws. Speaking of flexibility, Praegrandis has gotten an extreme upgrade allowing it to 1. Take more damage, and 2. Grow larger. The evolution of a rough spine. Some vertebrae extend into the dorsal fins. The final few form a structure into the tail of Praegrandis, making it more rigid, and the first vertebrae makes a skull-like casing for the brain. Praegrandis also, with its tongue, has a pretty good sense of smell. Praegrandis is the dominant species. The final descendant of Sylvosis lingua is Plectrum vermin. Plectrum is bigger than before. And the same as Praegrandis has, Plectrum has a sense of smell, and a better sense at that. On its arched back and the sides of, I guess you could say, its neck are regrowable red and black quills. These quills have no venom, but are very similar to porcupine quills, digging into the skin and flesh, causing pain, irritation, and sometimes debilitating injuries. Plectrum's skin is completely orange, making it harder for animals to find it in the first place. The teeth of Plectrum are uniquely shaped. The middle is serrated and they can be pushed back and forth like a saw. Not only is this for defending itself, but they use these to saw holes into bones, particularly ribs, vertebrae, and other thinner bones, and then they use their tongue to scoop out the marrow and eat that. For a moment between their marrow meals, they will eat soft fruit like Serenum pomes, Expeditus culmus berries, and more aged Caerulum folium fruit. Although the quills and teeth help prevent attack, smaller predators, like ones we will talk about much later, have an easier time with the quills, easily being able to attack around them. But all these predators have to deal with the new spine of Plectrum, which features far flatter and wider vertebrae than other animals. And Plectrum has a complete skull and lower jaw. And some vertebrae have rib-like structures that extend into loops all the way around in a ring. Most of these are in the bottom portion of Plectrum. There are also little bone structures where the quills grow out of. The next species we're looking at is Calum muscus. The first generation is made up of Breve muscus, Extenuatio muscus, and Gigans bula. Breve muscus. Breve muscus is a bit smaller, and with it a shorter lifespan, cutting into the length of Breve's flight length. Breve also has bigger leaves and a smaller root boulder. Extenuatio muscus. Extenuatio has an extra segment, I guess. Extenuatio has, although smaller roots, providing nutrients for a shorter period of time. It has a moderately longer flight time thanks to more efficient use of these nutrients, assuming nothing messes with it. Gigans bula. Bula is bigger than previously and has longer leaves, longer flights, and a more light bulb-shaped root. Bula, due to the severe space competition this family of plants needs, and the fact that Calum muscus and Ausoni motua have softer skin and flesh, making them a great food source for most herbivores, gigans would go extinct. The second generation, with hopefully some longer descriptions, is made up of Spiculum muscus, Rero muscus, and Velox muscus. Spiculum muscus. Spiculum is even smaller. Spiculum has a much smaller root bulb, more fitting their differing lifestyle. Instead of a longer flight getting a wide coverage of spores, Spiculum releases its spores in a much smaller area, more promoting only the stronger ones to survive rather than as many as possible. Spiculum, to help prevent predation from herbivores, has giant woody thorns at the end of its leaves, making it especially hard for larger animals to eat Spiculum. The leaves themselves are also bigger.
Reromuscus. Rero has even more segments, each one getting bigger and bigger. The roots of Rero have holes in them that theoretically would help shed weight for flight, but it does the opposite. The dust and sugar rock now is all still connected and takes more energy to lift. The benefit of this is while in the air, Rero attracts flying animals. Rero acts as a place to rest without the dangers of the ground. The sticking out dust and sugar provides a places to lay and grip onto the plant. Rero also flies lower and closer to the flights of animals. The benefit for Rero is that any animal might leave behind waste, allowing Rero to make use of them, extending the flight and helping to produce more spores. Velox muscus. Velox muscus, or vuscus, has significantly smaller roots than its relatives. These roots don't contain any dust or sugar, severely reducing the weight and energy needed to fly. The root also more closely matches the diameter of the stem, providing a more smooth exit. Vuscus now spreads its spore in the smallest area, being more of a radius around vuscus. This, although works, Rero and Spiculum and all other plants take up much of the available space, but not quite enough to force Vuscus to go extinct, just keeping it a rare species of plant. The next species descendants come from Minorella. The first generation is made up of Vitrum oculus, Crymatulus termes, and Encapistrocella. Vitrum oculus. Vitrum oculus, or voculus, is bigger than Minorella. Voculus has a transparent eye cover on its, eyes. This cover is to help them in their arid climate. Celera, and by Celera I just mean Hyalus and Minor, don't have eyelids. They both often just tear up to clear the eyes of any debris. But with the even dustier climate, Voculus has to put extra measures. The tear ducts now clear the transparent cover instead. Voculus has bigger claws yet shorter arms. Crymatulus termes. Termes has changed their shape significantly, being more cylindrical and longer. Most of Termes' arms have shrunk. The top two arms have small bits sticking out that capture both chemicals and smell to best determine where food is. Crymatulus also has a more omnivorous diet. With the bodily change in that only two arms are of significant size, Termes is a bit slower. Termes also is now toxic, mostly just tasting absolutely horrendous, but they also can cause irritation of the skin and inner lining of the mouth and throat, but not truly being dangerous to eat. And to display that poison, Termes is a dark blue with brown stripes down its sides. Termes' eyes have shrunk as well, along with the colors they see. Unlike previously being able to see just as many colors as you or me, now Termes can only see blue, orange, and red. Encapistrocella. Encapistro has a large webbing on its arms, making a capistro capable of relatively great speeds and gliding. Encapistro's arms have migrated to different positions and diversified. While the two side arms hold the membranes and claws for eating and defending, the top claw is just a vestigial part and has shrunk. The bottom three have turned into paddles. These assist partially for enhancing stability and maneuverability in the air, helping them turn, but they are also more or less used for attracting mates. And Encapistro has even changed how they see to amplify this. They no longer can see green, yellow, or teal colors, reducing the amount of distracting colors. The second generation is made up of Sanguinalis termes and Voans Sella. Sanguinalis termes. Sanguinalis is a little over double the length, and with this new shape, its skeleton has changed significantly. While Termes' skeleton had changed, Sanguinalis now has an extra flexible spine, with two bones attaching to one extra big vertebrae. And instead of a normal rib shape like all other organisms, Sanguinalis has these circular saw-looking ribs, and has a large, almost breastbone running down the very bottom of Sanguinalis. Sanguinalis' poison has gotten much worse for predators, now instead causing irritation of the skin, mouth and throat, vomiting, and internal bleeding in the stomach and the intestines.
And while all other poisons of organisms in the cup only hurt physically, sanguinolises both hurt physically and mentally, giving those who ingest it a massive feeling of terror and paranoia, often to the point of aggression in larger animals and isolation in smaller ones. And while being as poisonous as it is, sanguinalis benefits from all animals being able to see it's a problem. So sanguinalis has pores all over its body that can release a liquid that smells like burning rubber, as well as bigger brown spots, and sanguinalis makes high-pitched screeching yells and hisses to freak out predators. Sanguinalis, thanks to this new liquid it can release, can use this to cool down just like sweating, being the only animal who can do something of the sort, allowing it to handle hotter temperatures at least temporarily. Sanguinalis now only has 2 small eyes, and these eyes have a retractable, partially transparent lid membrane to protect the eyes. For Sanguinalis doesn't float and instead crawls. This actually allows Sanguinalis to go faster than both Cava and Minorella. But it also will expand the burrows of Cava Facies to fit inside. Sanguinalis has a diet of anything remotely soft, and the teeth are better suited for slicing bits of food off and swallowing them whole. While the back 2 limbs are nothing more than an extra warning symbol for predators, the side 2 are now much stronger and can be used to dig as well as slashing at predators. The top 2 have fully transformed into antennae. The top 2 bits sense chemicals that are commonly found in specific plant spores and decaying meat, and the bottom 2 are extremely good at smelling everything. This helps them find and avoid whatever they want. While Sanguinalis is a partially burrowing terrestrial species, they will go out into open soda in search of Gigant's hive mind for the alpha stems. Sanguinalis does get scared in open soda though, and prefers to climb on top of floating plants and debris, mostly because aquatic animals aren't as knowledgeable on the whole poison thing. Despite this, they are decent swimmers and can hold their breath for up to 20 minutes at a time, and they use their back limbs to help push themselves forward while tucking in their side arms. Sanguinalis is the dominant species. The final species here is Voancella. Voancella, or Voella, is fully capable of flight. But unlike other flying animals, where their flight is the major way they move, due to Voella's body shape and mostly the lack of forward-facing eyes while flying, they don't fly super often, mostly as a way to avoid a predator or get somewhere faster. Voella is bigger, but has smaller eyes relative to their body size. The top claw from before is now completely gone, and the side arms and claws now have a digit-like structures to assist with gripping and damaging enemies. The bottom 2 on the sides haven't changed, but the middle one has changed its claw shape. While Minorella and all of its other descendants just mate with whoever is available, Voella instead will have many females close in on a location, typically close to the one from the previous year. And as the females fly in the air, the males are on the ground. The males try to attract a female, and they can do a variety of things. While it actually varies a lot on what an individual female might want, the list includes carrying brightly colored objects, more impressively ones that are difficult to acquire like shell fragments or claws, making loud or unique noises, or a scavenged body. Although the location changes, the environment is always the same. These always occur on beaches, leaving the males vulnerable to a variety of predators. Males sitting closer to the soda are considered more brave and usually get more attention. After acquiring a mate, the 2 will find a sheltered location and lay their eggs there. After they hatch, the babies will ride on their parents' backs, and the family live a very nomadic life, typically following a herd of animals. With the change in their claw shape, they can't cut food as well, and Voella mostly eats softer fruits and berries, with the occasional leafy salad. The next species descendants are from Suki sabololis, and the first generation is made up of Senio armis, Stella commandentis, Odor molli, and Odor bonum. Senio armis. Senio is bigger than Suki, and relative to its size has bigger wings. Senio uses its wings more than before due to its increasing weight and the absolute size of a bubble Senio would need to rely entirely on it for flight.
Senio armis, although still relies on nectar for about 50% of its diet, to feed its more active lifestyle and larger size, it will steal meat from recent kills, or far less commonly, get kills themselves. That is to say, Senio is a kleptoparasite. The very front and very back sensors have heavily elongated. As mentioned in the past, the very front one exclusively smells, and now Senio's smell has improved. The middle and back sensors are for hearing, so Senio's hearing has also gotten better. These also act more like arms now, being stronger and having more finger-like digits. Stella commandentis. Stella commandentis, or Stamen delta, has specialized for a unique prey item. Instead of drinking the nectar from Dulkus flores, Stamen delta eats Rera radiolis stella. The second and third sensors have shrunk in size, making Stamen delta's hearing weaker, but the front sensor has many more segments, making Stamen delta's smell much stronger. But these segments are particularly sensitive to one smell, the faint but distinguishable smell of radiolis. This is required of Stamen delta thanks to its blindness and radiolis's lack of any noise. Stamen delta's beak is extra strong and hooked, allowing Stamen delta to pry a radiolis off of a plant and eat it. Although Stamen delta needs a way of getting to the radiolis and staying still for a few seconds to pry it off. The wings of Stamen delta are bigger and have a spiny edge to make them more grippy, but most of the support comes from the undersides of the arms. They have tiny, almost microscopic sections of skin that branch. They use van der Waals forces to stick to the plant and pry the radiolis off. Their skin is also green and wing plates a faint yellowish green to help camouflage against the lapis folium that radiolises are commonly found on. The nub on the back of Suki is now a large spike, helping to even out the weight a bit, but also helping to protect them in general. Stamen delta is also bigger. To help prevent flying into objects, Stamen delta has small hairs on its head that are extremely sensitive to differences in air pressure, which allows Stamen delta to a degree to detect objects nearby with some quick reflexes. Odor Molly. Odor Molly, or Odali, is a bit bigger than Suki. Odali is also partially a scavenger, eating long dead animals. They are also no longer attracted to the sweet flower smell of Dulkus. Now they like the smell of rotting flesh. Despite this, they are still mostly pollinators and have a longer tongue to help do that. They pollinate a specific descendant of Dulkus flores that you will see soon. To help with their scavenger lifestyle, they have small protrusions on the inside of their beak. These act like teeth to help rip and tear at flesh. Odali has an incredibly smaller third arm now being completely vestigial. Odor bonum. Odor bonum, or odonum, is slightly bigger. The ends of the wing plates are sharp and fade into red and then yellow as an early warning sign. While being as small as they are, they now travel in groups of 3 to 5, typically of one gender. An odonum will swarm any threats, latching on and cutting and scraping skin off. Odonum's first and second sensor has grown significantly. This is for the same reasons as Senio, to act more like arms. The third arm of Odonum is far larger to help with getting food from their new food source, Pendulus floris. This would lead to the evolution of Parampla spina. The third arm grabs into the large perched thorn and keeps Odonum still. The second generation is made up of Gelu venator and Vedit maxilla. Gelu venador. Gelu venador, or Gelnador, is far bigger than before, and is the largest of Suki's descendants. Gelnador has white fur covering its body, and where fur can't grow has gotten darker to absorb more heat. This includes the now brown wing plates and the dark red beak. A beak that now has teeth-like parts to help with Gelnador's predatory lifestyle. All the sensors now have a thick amount of segments to 1. Keep them warm, and 2. Heighten their senses. The main prey for Gelnador is Coriza and Dwilique, and because Coriza can't even make noise and Dwilique is no louder than the common wind around them, Gelnador has to really listen and smell out for prey. Oftentimes they aren't even flying and walk on the ground looking for prey. Another obstacle for Gelnador is the Sylvosis Lingua descendants. Not only do they complicate movement, but also provide cover for its prey. The barnacles themselves can be eaten, but the low-calorie meat and the pokey synthetic hairs are not worth the risk of falling into the mouth and then the stomach of them and then suffocating, killing both Gelnador and the barnacle. All these problems with hunting leads many Gelnadors to heavy intraspecific competition, and on occasion cannibalism. But the ones who can survive are ferocious predators. Gelnador has a smaller, now vestigial third arm. Gelnador has now a far stronger bite. Gelnador relies almost entirely on its wings to support it. The bubble now just helps in supporting its weight. Gelnador is faster in the sky. Gelnador is the dominant species. Vedit maxilla. Vedit maxilla, or Vaxilta, is now totally a kleptoparasite and a scavenger, relying entirely on other animals to make kills and Vaxilta to steal them. Vaxilta's jaws are serrated, now incredibly sharp and grippy. These jaws can also bite down harder. This combo allows Vaxilta to cut through some bones and also give heavy lacerations to anything that wants to get its food back or scavenge the same carcass. The ends of the wing plates are more rounded, allowing for more maneuverable flying, allowing Vaxilta to dodge and weave to the best of a blind animal's capability. The front sensor of Vaxilta has more segments, allowing them to smell for food far better. The third arm has undergone an interesting change. It has small parts sticking out of it that act like canards. This helps a bit with staying stable in the air and dodging and weaving. The arm itself has really been reduced to just the uppermost part. The next species we will talk about is Dulkus floris. The first generation is made up of Angulus floris and Ransens floris. Angulus floris. Angulus is practically identical to Dulkus floris, only facing up a little bit more, making it a little bit taller. Ransens floris. Ransens is shorter than Dulkus. Ransens has thicker, dark green skin. Ransens has no normal leaves, instead has a head with 2 thick ones that can open and close. Inside this head is many stiff hairs that release spores when moved by either the wind or an odali that comes to pollinate it, because Ransens still does have nectar. Ransens has a smell similar to rotting flesh. Ransens, with its lack of leaves and being less reliant on pollinators, can survive in warmer climates. Ransens, also with its large roots, will hold soda if need be. Ransens, thanks to a lack of leaves or fruit, large size, and horrid smell, doesn't have to worry about being eaten very much, but it will have to deal with an unexpected problem you will see later due to its horrid smell. Ransens is the dominant species. The second generation is made up of Sugar Dominus and Procerus robur. Sugar Dominus. Sugar Dominus, or Samgar, is even taller, making Samgar one of the tallest plants in the cup. Samgar has not just more leaves, but some longer leaves. Samgar's stem starts orange and fades to brown towards the top. This helps put more contrast on the brighter leaves and make them more noticeable. The nectar and even just general sap of Samgar is by far the most sugary out of any plant in the cup. Samgar also produces more nectar for pollinators. Samgar now has a much taller top leaves. This helps with photosynthesis and helps block soda from getting into the flower. To further avoid this, there are spaces between the bottom petals that allow soda to fall out. Samgar's root is wider, allowing access to more soda. By being just bigger in general, Samgar's flower serves as an even better nesting spot for flying animals. Although a bit small for Penna army descendants, it's perfect for Suki sabololis descendants. And even ones who don't eat from Samgar will nest in it. Procerus robur. Procerus robur, or proberus, is pretty similar to Somgar, except proberus is even taller and its flower faces completely up. This makes proberus the third tallest plant in the cup. Proberus has a less sugary nectar. Proberus has longer petals and more of them. With its petals more spread out, proberus is a better nesting spot for larger animals. And the babies of these animals can subsist off the nectar at least partially, thus removing some stress for the parent. This also gets the children and adults covered in proberus's spores. A common animal to nest in proberus is Rauca lingua and its later descendant, Natatorius column. Proberus also has wider reaching roots for more soda and nutrient access. The next species descendants are from the ever so important Folium. The first generation is made up of Stips Folium, Circumfolium, and Grandis Folium. Stips Folium. Stips Folium, or Stolium, has a shorter stem and longer leaves. Stolium can grow faster than Folium, and that's about it. Circumfolium. Circumfolium, or Cerium, is taller and generally bigger than Folium. While the top of Cerium is still that brownish orange, the stem quickly fades to white due to it mostly being in the shadow. Cerium has more bulbous roots to store soda, and you could probably guess what that means. Cerium is adapted for the more arid savanna and steppe, being the dominant ground vegetation in these environments. Grandisfolium. Grandisfolium, or Grolium, is taller than Folium. Grolium is stronger than Folium. Grolium often forms small patches of tall grass, and that's it again. The second generation is made up of Brevisfolium and Altafolium. Brevisfolium. Brevisfolium, or Brolium, almost has no stem and has even longer leaves, being almost identical to grass at this point. The bottom portion, similar to Cerium, is paler due to the less light it receives. Altafolium. Altafolium, or Alita, is a lot taller and stronger. Due to Alita's relation with the fastest growing plant, Alita can grow quite fast for their size, which can help it survive in less predictable environments than other similarly sized plants. Alita can also regrow after more damage better than other plants. The next species descendants are from Rera radiolis stella. The first generation is made up of Mobilis stella, Vertiginosus stella, and Arcus stella. Mobilis stella, or Stabella, is a bit bigger than Radiolis. And despite only being a little bit bigger, Stabella only grows on the biggest plants, including Dulkus flores, when available microlignum, and most commonly Lapis folium. In specific conditions, like it being too hot or cold consistently, it's on a dying plant, or it's in quite an uncomfortable position, Stabella will detach from its plant and either run to the other side of the plant, or more commonly to a neighboring plant to hopefully find better conditions. Stabella needs to overcome some extreme challenges first, number one being breathing. Rera radiolis simply absorbs oxygen from its host, and a small portion from diffusing with the hole on top of it. But when Stabella detaches from its host, it needs a way to get more oxygen. Stabella has two very small hair-like tubes that absorb oxygen from the air. These are not enough to fully supply Stabella with the O2 it needs to survive, but it does extend its time that it can survive without a host to about 2 minutes instead of about 50 seconds. Stabella will charge with relentless energy and not stop to even acknowledge anything else, even if it's being attacked. Another problem Stabella has is climbing a new host. Without strong limbs, they can't cling to anything and will just fall off. To compensate, they produce a sticky adhesive, sticking them to their host plant. This also prevents their skinless meat from drying out. The third and final problem is reattaching to the plant itself. Stabella's claws are extra sharp and easily punch into the plant. While 3 attach, acquiring nutrients and O2, the 1 will carve a space needed to properly sit in the plant. And because they detach from plants, Stabella no longer integrates its shell into the plant's skin. Vertiginosus stella. Vertiginosus, as the coloring suggests, is toxic. And the toxin it has is specifically designed to screw with stamen delta. but still works against any other animal eating it. Its poison causes both vomiting and a lack of balance, similar to being very drunk. This specifically screws with Stamen Delta because it flies as a primary way of moving, and their walking is already very slow and disorganized. So if Stamen Delta eats vertiginosus, they essentially can't fly without hitting something. And when combined with the vomiting, vertiginosus will make Stamen Delta very hungry, and an encounter could be life-threatening. To help Stamen Delta recognize it, vertiginosus's smell is different and its shape is different from others, making it physically harder for Stamen Delta to pry it off. Arcus stella. Arcus stella, or Arcella, is very similar to Rera radialis. In fact, it's the exact same except for the fact that individuals can be different colors. Arcella can't consciously change colors. Instead, different plants produce different amounts of sugars and different chemicals. And depending on the many different variables, they will change between a bright orange or a dark green. This works most of the time. The only exception is Rancen's flores, who triggers the orange color, but it's green, leading to the opposite effect. This adaptation helps Arcella against other animals eating it, but not the blind Stamen Delta. The second generation is made up of Ambulatio stella, Spinosus stella, and Terra stella. This generation is also the second species to have a first generation species both stay the same and have a second generation. Vertiginosus stella has descendants, but is also still present. The first was Natantus huverus. Ambulatio stella. Ambulatio stella, or Stembulatia, can now fully survive without a host plant. They now walk around in search of scraps of food being anything dead or rotten. Stembulatia can also still stab a plant to suck out nutrients and water. Stembulatia walks using two of its arms that now have blunted claws. Two others can pick up chunks of food and bring it to its simple mouth with tiny teeth. Stembulatia is bigger than previously. Stembulatio's breathing mechanisms have improved significantly. The branches that absorb air will no longer dry out and can absorb plenty of O2. Stembulatia's skin is much thicker now, preventing it from drying out, but not protecting it all too well. This skin is also mostly transparent. Stembulatia is a potential prey item for particularly large Anthrophagus fister individuals. Stembulatia has two major problems, the first of which is what to do with gametes now that they no longer attach to plants. Stembulatias, when they find another, Stembulatia males will release their gametes through the holes on top of them, and the females will catch them. These then fertilize her gametes and she creates tiny rudimentary eggs. An individual egg can have up to 100 young inside of it. These young will eat each other while developing for nourishment. When hatching, only 5 or 8 will remain. She will lay anywhere between 20 to 30 eggs and sit on top of them to protect them. After hatching, the young don't have shells and will have to look for food on their own, because mom is already gone after they have hatched. These babies will eat anything soft they can find and will often swarm fallen fruits or bits of meat. Many babies will also stab into plants and stay attached to them. The other problem Stembulatio has is the next species we'll be talking about, Spinosus stella. Spinosus stella, or Spitelosus, has many of the same attributes as Stembulatia. The difference are, Spitelosus is slightly taller, is a decomposer and a detritivore. Spitelosus has spikes covering its shell. Unlike Stembulatio, Spitelosus has its mouth protrude and a tongue-like organ protruding from that. Spitelosus also has many tiny teeth. Spitelosus is originally adapted to the caves, being where they originally evolved. But many would accidentally leave the caves, but find life about as easy. Spitelosus would start outcompeting Stembulatia, but not to extinction, mostly due to Stembulatia's better reproductive rates. Spitelosus reproduces very differently due to the caves lacking many resources. It starts with males and females all surrounding an at least decently sized body of soda. They all release their gametes and many fall into the soda and mix. These eventually turn into larvae, and between the surface spitallosis and the cave spitallosis, these larvae take very different forms. The cave larvae will stay small and at first eat floating debris and unfertilized gametes. Once they get too big for that, they begin to eat each other, and they progressively get bigger and bigger. Eventually, they form their shells and move to land to become a normal spitallosis. This takes about 2 to 2.5 weeks to finish. But the ones on the surface are very different. These larvae get much bigger than the adults. They first also eat debris, but the bigger they get, the more ferocious they get, and they will eat anything they can get their tendrils on as long as it's small enough. They mostly subsist off the detritus accumulated on plants. These larvae also have a very thin bone on the inside of their body. But these babies, after 6 to 7 weeks, will stop eating and begin to shrink. They develop their shell and lose that tiny bone. After about a week of development, they become an adolescent spitallosis. These two different ways of larval development make it so surface spitallosis could be considered a subspecies of spitallosis. Although the larvae of the surface spitallosis get bigger than the adults, they commonly fall to smaller Nintantis aquaticus descendants. At first starting with Nintantis proboscidinos and partitionus, but eventually when the third generation rolls in, it's Nintantis cyclopsis and tripoglossus that hunt the poor larva. Spitallosis can still fall prey to Anthrophagus pfister, but thanks to its spikes, it's less likely. Terra stella. Terra stella, or Terrella, is completely pale and like its still-living surface ancestor. Terrella is also smaller. Terrella is still toxic, even more so than its ancestors. Terrella is in a symbiotic relationship with a plant, one we talked about long ago, Toxicus hospes, a descendant of Maximus foli. Terrella supplies hospes with poison, causing animals to become essentially extremely drunk with more vomiting. And Terrella gains the free sugars and nutrients extracted by hospes. Terrella also sits on the roots of hospes as not to block photosynthesis or attract attention. Terrella, to make sure its future children have a hospice to grow on, will attach fertilized gametes to a spore of hospice and hope that all goes well. Terrella can attach a fertilized gamete because hospice always has at least 2 Terrellas and at most 4. Reproducing means pumping gametes into the plant and then meeting there. Terrella can transition to the other gender and reproduce then, always being able to reproduce now. Although this means that the species as a whole has a rough time diversifying the gene pool, with this way it seems as if they don't really need to. Despite this whole relationship revolving around poison and vomiting, they will get exploited for this by a later species. The next species descendants are from Claris kimex. The first generation is made up of Minuspeds and Pollex kimex. Minuspeds. Minuspeds, or Minides, is, well, boring. Being almost identical to Claris, except it's gone through centaurism, lifting its front 2 limbs off of the ground. And it's less likely to attack at first. Pollex kimex. Pollex is far more interesting. Pollex has diversified its food palette. Now if it stumbles across small enough eggs, it will eat them. This helped propel not only centaurism, lifting its front 2 limbs off the ground, but also a thumb-like digit to help grab eggs. The second generation is made up of Macer kimex and Nisus kimex. Macer kimex. Macer kimex, or Mysex, has longer limbs. Unlike Claris and Minides, who walk parallel to the ground, Mysex stands upright. Mysex's teeth are more narrow and duller. These teeth are for crushing fruit, primarily Caerulum folium's descendants, of which make up about 70% of Mysex's diet. The rest is Expeditus culmus berries and Serenum pomi fruit. The back limbs of Mysex are more spread out to better bear its weight. Mysex is also far calmer than its relatives due to its larger size. Smaller predators and less experienced medium-sized predators often leave Mysex alone. Nisus kimex. Nisus has thinner back limbs. Nisus also stands more upright. Nisus's thumb is longer and the sort of palm of their hand has better grip. This gives Nisus a better grip on objects they use to do a variety of tasks, from using large leaves to protect them on rainy days, to use a thorny, dried plant to smack another creature, or simply fiddling with something in pure boredom. This grippy palm also helps with their new climbing life. Nisus will climb into trees to get to the eggs of nesting animals, or to get away from a problem, or to find a spot to sleep. To further help in its climbing department, the shoulders of Nisus are extra flexible. Nisus's rattle is smaller and not as loud as its ancestors, but still noisy. Nisus has an incredible sense of smell and can recognize smells for years, and their brains can easily determine where a smell came from. But right behind their brain is a small organ. This organ is full of sensitive hairs that evolved from nerves. This is connected to their hearing and is a very poor, rudimentary form of echolocation. All these almost require the furthering of Nisus's intelligence. Nisus is also now green, better camouflaging than their blue, but is still not great. The third generation is made up of Quasito kimex. Quasito kimex, or Quasitex, is a little bit smaller. Quasitex is arboreal, now having hyper-flexible shoulders and far bigger hands, with even better grip. While about 55% of the population resides in swamps, the rest can be found in the savanna or plains. Quasitex's saliva is very sticky, thanks to a specific descendant of Brevis poto, and from special proteins. Quasitex is even smarter and revolutionized a particular concept: rudimentary clothing. First, it just started as they made their nests comfier and stronger, but it turned into a habit of connecting plants and using that to block rain. But now they take plant thorns, fibers, and flatter leaves and weave and connect them together. They understand that some clothes, particularly ones made with the swamp leaves, can protect you from the rain best, and that animal pelts, skins, and furs can keep you warm. While they don't understand how these work, Quasitex understands how to make them and that they do work. Quasitex is now also omnivorous and will hunt small prey, though fruits make up most of their diet, particularly the fruit of Brevis poto, just like its ancestors. Brevis poto, who was mentioned in the original documentary, is very potato-like, even being as starchy. And you will see but one descendant has a very hard time giving up its fruit, and Quasitex is pretty good at getting the fruit. And the starchy fruit are what helped start the clothing revolution. The starch can be processed into a glue-like substance for Quasitex to help keep things together. Back to the physical changes, Quasitex is also orange, camouflaging much better. The rest of the limbs of Quasitex are far smaller, but these do still get used when not swinging from leaf to leaf. These can also hold onto an object of interest, or help make clothing by knitting and weaving fibers or leaves together. Quasitex's echolocation is better, but still not great. But this does still give them an incredible advantage over completely blind animals. And although Quasitex's rattle is even smaller, it's still plenty loud enough to give the Quasitex a good idea of its surroundings. To go tree patch to tree patch, Quasitex can still walk along the ground. Their strong arms on their own let Quasitex crawl. This is when it's most vulnerable, but that's not to say Quasitex is defenseless. Quasitex is the dominant species. The next species descendants we are looking at, also marking the halfway point in our list, is Homunculus. The first generation is made up of Avioradix, Brevis radicatus, and Sanctus Callus. Avioradix. Avioradix, or Avadix, has longer, more branching roots than Homunculus. The holes on Avadix's stem are bigger, but fewer. Brevis radicatus. Brevis radicatus, or Braviditas, has far shorter roots. Braviditas also has far fewer holes in its stem. Both the roots and the holes are a result of now no longer having an oxygen shortage like its ancient ancestors. The holes on the top of the stem reach further and split the stem. Brevidatus is also taller and has deeper roots. Sanctus caulis. Sanctus is taller than homunculus. The roots of Sanctus are more specialized. They store thousands of spores in their tissues, and the roots are a bit softer and break off easier. This is for an Entantus hooverus to swim by and eat the roots, thus carrying a portion of them upstream. Sanctus, unlike the others who are more adapted to life in the many ponds and lakes, the Sanctus is more adapted to the rivers connecting those up, because most ponds and lakes are interconnected, being why there is no sea or ocean. Back on track though, Sanctus also has more holes. The second generation is packed with Radix hijacker, Tresfolia, Album herba, and Seminarium caulis. Radix hijacker. Hijacker is quite a unique plant. It starts its life mostly normal, but smaller and a more simple stem. But eventually, hijacker grows massive thorn-covered roots. These roots are in search of a gigant's hive mind. They search the many individuals for an alpha stem. When found, the root detaches and begins to grow a more familiar stem. After it finishes growing its adult body, hijacker will begin to wrap its root around the root of the stem and the stem itself. Hijacker will integrate its spores with the colony's spores, and eventually the stem will explode, releasing those spores to hopefully start a new colony, and soon after, the seedlings will grow. Although the stem does sap nutrients from the colony, the sheer size of the colony means that it doesn't really matter, and the alpha stems don't photosynthesize. The roots that wrap around the stem and root help protect from both Rosea hider and Sanguinalis, who love the taste of hive mind alpha stems. The roots still have thorns and don't prevent the stem from doing much, so both sides get benefits, but hijacker gets the better deal. Hijacker is the dominant species. Tresfolia. Tresfolia, or Folura, is the biggest member of this family. Instead of the splitting stem from before, Folura has 3 separate stems, each ending with 1 leaf. These often stick out of the soda. Folura's stem also fades, being darker on top and lighter on bottom. Folura has no small branching roots. Folura has only ever 3 holes. The side 2 release spores and the middle one intake spores, and then processes them into a fully developed spore. The trigger for releasing spores is when sudden movement happens near the holes, i.e. most often when an Entantus hooverus is eating or just swimming by. Folura really relies on hooverus to spread its spores. Album herba. Album herba, or alherba, is quite different. The stem is pure white and the only 1 leaf they have is much paler. Alherba has bigger holes in its stem, and its stem is more flexible. Alherba has nubs at the end of its roots. These are more recognizable for an Entantus hooverus, and these nubs are quite flavorful, being very sweet. These nubs also hold spores. This encourages hooverus to eat these roots and spread those spores. The reason that alherba is so pale is that it no longer needs to photosynthesize. There is a massive amount of rotting plant matter, dead animals, and feces at the bottom of riverbeds. Alherba is a decomposer and has long fibrous roots reaching a far area around it. Alherba, along with hooverus, keeps the floors clean and less rotten. Seminarium caulis. Seminarium is taller than previously. Seminarium has a lot more holes in its stem. These holes are great places to lay eggs, rather than on the floor where they can get thrown around and accidentally eaten by a hooverus. Seminarium is the holder of many species' eggs. Some plants can be holding multiple species' eggs at once. The species' eggs it holds most often are Natantus nidalicus, Natantus cyclopsis, and Rosea hider. Other eggs can be found in Seminarium, but simply less commonly. The benefit for Seminarium is these animals have a chance of touching their long roots that easily stick to things, and these roots also spread spores from there. But Natantus huverus is again what spreads 52% of the spores, being the third species to rely on huverus. The next species descendants are from Microlignum, whose first generation is composed of Multe princeps and Extenuatio foli. Multe princeps. Princeps is mostly the same as Microlignum, now just having more heads and being taller. Extenuatio foli. Extenuatio foli, or Folenwatio, is also largely the same, now being a bit taller, having more, thinner leaves, and overall a stronger stem. The second generation is made up of Titanus arbor and Spondit arbor. Titanus arbor. Titanus arbor, or tarbor, is the largest plant in the cup, and it has between 5 to 8 heads instead of the 3 to 4 of Princeps and the 2 of Microlignum. To support its size, Tarbor's version of wood is even stronger than either Princeps or Microlignum, with its thick outer green layer surrounding it. Although some tarbors live in fields few and far between, many live in large forests surrounding large permanent lakes and rivers. Tarbor size actually varies a lot. In fields where they are few and far between, they grow to about 50 micrometers tall, but in their forests, due to both the extra soda and competition from other tarbors, they can get 80, 90, sometimes 100 micrometers tall. Spondit arbor. Spondit arbor, or spondor, is taller than previously. Instead of leaves, they have bristles that still function the same. Spondor not only has the woody body like tarbor, but also a rough, dry, and thick skin, basically being like bark. This makes it harder to be eaten or radiolisized. While most are found in savannas, about 72%, about another 23% are found in the plains, and another 5% are found in tundras, which can really screw with most of Sylvosis' descendants, both due to the space they take up and the amount of light they can block. Although other animals love the fallen bristles, or to use the branches as perches. Branches that help defend against the few who can reach its bristles. Spondor is the dominant species. The next descendants are from the colossal Titanus kimex. The first generation is made up of Grandis kimex and Tumultus kimex. Grandis kimex. Grandis kimex, or Grandex, is even bigger, eating whatever plant matter they can reach. They also have a longer neck and a bigger arm claw. They also have a small dewlap for better heat exchange. Tumultus kimex. Tumultus is smaller than Titanus kimex. It also has darker skin, now needing the camo a little bit. To help with thermoregulation, Tumultus has these small skin flaps on its sides. These not only increase the surface area, but can also be fanned to blow around cool air. Tumultus's back 2 legs are weaker and thinner. Tumultus's front arm is longer. The second generation is made up of Titanic Maximus and Lacina kimex. Titanic Maximus. Titanic Maximus, or Maxidicus, is the largest singular organism within the cup. Maxidicus can be anywhere between 37 to 40 micrometers tall. Here's a visual of how that is compared to other animals. Maxidicus, being the momentous size that it is, requires a lot of food. To help cope with this, 2 major evolutions have come to be. One being its directional sense of smell. The breathing pores on its snout, not to be confused with nostrils, have enlarged, taking in more air. And Maxidicus' sense of smell has majorly improved, being able to smell food and soda from remarkable distances, thousands of micrometers away. Another helping matter is their longer neck. Titanus and Grandis kimex have relatively short necks with a limited range of mobility, while Maxidicus' neck can easily reach to the floor and eat much of the fruits and plants below, as well as eating the leaves of the tallest plants. Maxidicus doesn't really have to worry about what it's eating, with the thorns of plants being no more than a nuisance.
And even the poisonous Toxicus hospis and spicy Condidus dangiflora don't affect Maxidicus all too much. All this allows Maxidicus to eat essentially anything. The only exceptions are plants outside of its territory, but also transcends flores due to the smell throwing off Maxidicus, as well as the woody stem of any plant and the sugar stone leaves of Lapis Folium, as well as the few that are too tall. To continue with its food requirements, Maxidicus will gnaw on bigger bones and swallow smaller ones. Another problem with its massive size is heat. To help, not only is a blood vessel-filled dewlap in place, but also on its head, neck, and back are tons of tiny gray lumps with a singular hair on each. These each help move heat away from the body, helping cool the body down. Maxidicus's legs have changed a bit, with the back two pairs being more curved and the bottoms of them all are flattened. This mostly helps with preventing the previously pointed legs from sinking into the ground, but also with supporting the mass of its body. In fact, Maxidicus has for the most part hit its biological size limit. While with continued evolution, Maxidicus could deal with heat, like even larger dewlap or even more dewlaps on, say, the thighs. The bigger issue is the immense amount of food it needs to survive. There's simply not being enough food for a much bigger animal to survive. Maxidicus's arm claw are even longer, thinner, and sharper, making it more deadly not only to potential threats, but also other Maxidicuses. Maxidicus is rather territorial, especially against other members of its species. Due to the increased demand for food, sharing with others is a waste. To keep other Maxidicuses out of its territory, Maxidicus lets out constant bellowing calls to ward off trespassers, though females use these to track down louder males, being the only time they tolerate each other. Maxidicus, if it finds a big enough body of soda, will walk in and take a seat. This helps cool down Maxidicus, drowns any parasites on it, and lets animals like Natantus hooverus eat its dead skin off it. Maxidicus will also eat any descendant of Cardoradix it can reach, benefiting those under the soda. This can also completely reshape aquatic habitats. Maxidicus is the dominant species. Lacina kimex. Lacina kimex, or Simina, is a bit smaller than its ancestors. The front two legs of Simina are especially strong, with extra dense bones and powerful muscles, especially in the second pair. The back two legs are lifted off the ground. This reduces the energy needed to walk. But the back legs are not vestigial. They are still strong limbs, and with their chitin exterior makes them great at dealing with enemies attacking from behind, being able to kick enemies away and run away in the process. Despite being smaller, Simina isn't exactly the fastest animal, but it makes up for it with great stamina. To help with said stamina, as well as both the heat of its savanna and occasionally desert life, and to help with balance, the flaps on the side of Simina's body are bigger. When Simina is about to fall over, or when Simina is just scared or hot, these flap as a way to help cool down and not fall over. With Simina being much smaller, it now has to deal with the many predators of the cup, and acts as a potentially risky, potentially incredible food source for many. Larger predators have no issue dealing with the back legs, or just attack from the front if it has the foresight. The next species descendants are from the Bidesisolto whose first generation is made up of Viso antiparasiti, Caerulis parasiti, and Azu parasiti. Viso antiparasiti, or Viantiparo, is a lot bigger than Sisolto. Viantiparo's sense of smell is stronger now. Two simple eyes are present. These eyes only see light to dark, but even this enhances its ability to find food and avoid danger incredibly. And unlike Sisolto, Viantiparo has to continuously look for food now, since now it's another species that eats Rera radiolis stella's descendants. And with its eyes, Viantiparo can tell the difference between radiolises, avoiding the contrasting toxic ones. To eat a radiolis, Viantiparo, unlike Stamen delta who pries off radiolises from the plant itself, Viantiparo uses 4 large teeth that crush through the shell and eat radiolis still attached to the plant.
For this, Viantipero's teeth are quite a bit stronger and can bite down harder. Viantipero's reproduction has also changed. Now, instead of females laying their eggs and dying, with the males looking after them till death, the female lays her eggs, leaves, and the male watches over them for just a little while. Caerulis parasiti. Caerulis parasiti, or paracultus, is a mixture of blues instead of the orange and yellow of Sisolto. This is for attaching to Claris and Titanus kimex instead of Radiolis. And two little wing-like structures allow paracultus to glide short distances, but still improving its chances of landing on its target. To get through Titanus kimex's thick skin, paracultus's teeth are sharper. Azu parasiti. Azu is the same palish yellow of Radiolis and has less spots, making it less noticeable to otises when attached. Unlike other Sisolto descendants, its tail does not have a split end. The second generation is made up of Colossicus dentis, Ruminovermin, Venatovermin, Omniparasiti, Exoptoparasiti, and Sabololis parasiti. Colossicus dentis. Colossicus dentis, or Dentolicus, is extra specialized for eating radiolis. With two giant teeth that can easily rip a radiolis off of a plant, and using its 6 sensory hairs it can rotate radiolis and begin eating the meat under. Its eyes are also able to see most shades of green. Dentolicus moves quite slowly to really look for hidden radiolises, or look and smell out for a Ransens flores. Dentolicus's 2 large teeth have special blood vessels that can close when full, making them stiff, allowing it to pry off a radiolis. But when not closed, these teeth can be moved out of the way for eating. Ruminovermin. Ruminovermin, or vermino, is the second largest of all the descendants. And while eating radiolises in the past, some plant would often get in there, so some fully transitioned into eating the plants. Vermino eats just the outer skin of plants and leaves, leaving the more vital parts of the plant intact. Vermino is most often found eating the outsides of Arbor, over time leaving many scars that last years. Vermino's eyes can see green and red. With Vermino mostly living in forests, its food is not particularly difficult to find, and such its sense of smell has worsened. It doesn't come into use very often. Vermino is the dominant species. Venatovermin. Venatovermin, or Vernadin, is even more of a predator, but despite being the biggest of Sisolto's descendants, Vernadin has to hunt much smaller prey. Prey such as baby animals, walking Rera radiolis descendants, Cava Facies, other Sisolto descendants, and a bit less commonly some Penna army descendants, Angula, and Inunium vagus. But Vernadin can easily fall prey to bigger predators, or be killed by even just small herbivores. To help with its predatory lifestyle, Vernadin has serrated teeth to cut through flesh. Venato's sort of lip is longer in the front to help keep prey in place. Venato has also grown more vertical eyes, allowing it to better spot prey and danger in the tall plants. Venato is more protective of its eggs. Instead of males only watching their eggs for a little while, Vernadin watches them until they hatch. Omniparasiti. Omniparasiti, or Omniceti, has further increased its quote-unquote wings to assist in gliding further. Omniceti has the best sense of smell out of any of its relatives. Omniceti now parasitizes larger Trandiferous species, including some Trandifer descendants, Ugnus ambulans, and Caeca chaser descendants, as well as Titanic Maximus and Macer kimex. Exoptoparasiti. Exopto is thinner and longer. Exopto hides in the folium instead of on top of tall plants. One tooth of Exoptos is extra strong, sharp, and big. This is to give Exopto a much better grip on its host. Exopto will also curl up into a ball when disturbed, or when attached to a host, Exopto will thrash its body around, or if possible, wrap itself around its host.
Exopto reproduces differently. Instead of females laying their eggs and soon dying, leaving the male to defend the eggs, instead, when two exoptos mate, the male will follow the female and help find a good place, and then the female will dig a hole into the ground, and then the two parents simply return to feeding. This form of reproduction also applies to Sabololis parasitae. Sabololis parasitae, or sabolisti, is a bit thicker than previously. This is because of the giant lungs that sabolisti has. These lungs are for hissing and screeching when being removed, disturbed, or being hurt. Two of sabolisti's sensors have gotten much longer and not only smell better, but are also used to feel and find any crevices on a host to hide in. But most Lataotis descendants will attack sabolisti on sight, so sabolisti will fatten up, fill its stomach with blood, and detach when the individual goes to sleep, minimizing dangerous time with its host. Sabolisti's arms also have hooked ends that are extremely grippy, helping it reach previously unreachable places. Sabolisti will hide anywhere with a decent amount of coverage. The third generation is only made up of Alaparasitae. Alaparasitae, or Alacetae, has much bigger wings. This, along with some internal changes, allows Alacetae to finally fly. Alacetae isn't a great flyer, going against the wind is basically not an option. But at least now, Alacetae's attaching attempts are extremely successful. These wings also help with swimming, acting as fins. The sensors on Alacetae are more complex and can sense even the slightest change in air pressure, basically allowing it to sense when something is moving around it without seeing it, making its attaching attempts even more successful, and also allowing it to avoid danger better. Alacetae also reproduces differently. The only difference, though, is that females don't give males any stored blood they have, and once the female lays the eggs, she returns to feeding. The males don't always die when protecting the eggs, but they have an 85% chance of dying. Alacetae is also a bit bigger.
The next species descendants are from Brevis Podo, whose first generation is made up of Duopodo and Praefixipodo. Duopodo. Duopodo is almost identical to Brevis Podo, now with just two heads and facing upward. The stem also fades to a darker green at the top. Praefixipodo. Praefixi is also almost identical to Podo, even more so, now with just thorns on its stem, minus the end, and a few thorns on its roots. The second generation is made up of Gemine Podo and Jaculor Podo. Gemine Podo. Gemine is also quite similar to Brevis Podo, which makes sense. Brevis Podo is already incredibly well adapted and has many advantages over other plants. Gemine has a quickly fading stem, and without the fruit, leaves grow in their place until enough resources are gathered for more fruit, which doesn't take long. Gemine also has permanent leaves in between its heads. Jaculor Podo. Jaculor is taller than previously. Jaculor has a more unique way of spreading its seeds. Although its fruit looks the same, it's far less nutritious and has no seeds. Once the fruit is eaten enough, the plant will release organelles holding an immense amount of water, a sticky sap-like substance, and smaller seeds. These seeds will stick to the face of whatever was eating the fruit. After about 5 or so minutes, it dries up and the seeds begin to flake off, getting to the ground faster than going through an animal's digestive system. And even ones who don't get on the face will get on other body parts, or launched far enough that they won't be a problem for the parent plant, which usually leads to small, dense groups. Jaculor also is primarily found in the savanna. Jaculor is a common food item for Quasito. Jaculor is the dominant species. The next species descendants are from Expeditus culmus. The first generation is made up of Spinosa palma and Digitus culmus. Spinosa palma or Palnosa is taller than Expeditus. The single leaf of Palnosa is bigger and goes higher and fans out. The stalks that the berries are attached to are longer. On Palnosa's quote-unquote hands are covered in thorns instead of the just two. Digititus culmus. Digititus culmus, or colgatus, has 3 fingers instead of the just 2 thorns directly connected to the arms. These help provide more intricate movements. The thorns of colgatus are thinner and longer. The second generation is made up of Grandis alapa, Floralis equus, Vigilantis bacchus, and Avio ambulo. Grandis alapa. Grandis alapa, or Grandalpa, no longer walks, but instead tension is built up within the 3 fibers in each arm. Once the animal triggers the plant fibers by doing too much damage or bending the plant too far, these fibers will snap, throwing the thorn-covered hand and arm at whatever was damaging it. And with these thorns being iron-embedded, they can do plenty of damage. These slaps can and will bruise and cut most animals, although it takes over a week for the fibers to regrow and reset. These slaps also tend to rip and cause tears on Grandalpa's surface. To prevent an animal from eating its berries triggering the arms, the berries reach further away from the body. Grandalpa has a bigger leaf. Thorns don't just cover the hands, but also a row goes up the arm and towards the leaf. Floralis equus. Floralis equus, or Florquus, is completely covered in thorns except for the top portions of its body. Florquus does walk, although less than its relatives. The leaf on Florquus is bigger and overlaps the top part of the plant. Florquus are also taller. The berries have significantly shorter stalks, merely as a byproduct of evolution. Vigilantis bacchus. Vigilantis bacchus, or Vigilantas, has its berries looking like eyes. This is simply to make the berries more noticeable to those with vision as merely coincidence. This only affects animals with vision, and some animals do get spooked by these occasionally, although it's usually younger and less intelligent individuals that get spooked. Vigilantas walk less, but not by a whole lot. The roots of Vigilantas are bigger. Vigilantas is the dominant species. Avio ambulo. Avio ambulo, or Avambulo, is the tallest in this family. Avambulo has shorter berry stalks. Avambulo walks more often than its ancestors. As such, its walking has gotten more efficient and less energy wasting, also allowing Avambulo an extra day and a half to find a new place to root. They'll also take root in unoptimal places temporarily to at least partially replenish some of its energy and resources. The next species descendants are from Arasibuca, who was, as mentioned before, was declining in population and will evolve into some bizarre forms. The first generation is made up of Mortis buca, Admus retro, and Sainese buca. Mortis buca. Mortis buca, or Mortuca, has thicker jaws and in turn a stronger bite. While Arasibuca was more keen on staying in one spot and waiting for prey, Mortuca is more active, slowly searching for prey. Mortuca is largely in competition with Debilis venenum, and unlike later duplex maxilla, Mortuca could not coexist with Debilis venenum or later venenum fox, and in turn is extinct. Admus retro. Admus retro, or retrado, has slightly thicker jaws. On the sides of its body, 3 ribs have elongated and serve as very rudimentary legs. These ribs are extra flexible and are covered in a thick layer of skin. Unlike Arasibuca, who has where every layering in their skin has a black stripe, Retrado has a rough diamond pattern on its back. Retrado only attacks much smaller animals and is more relaxed around larger ones. Sainese buca. Sainese is bigger than Arasibuca. Sainese has its head rotated, where Arasi has its jaws parallel to the ground, while Sainese are perpendicular. While Arasi's jawbones have many segmented parts, Sainese has its upper jaws fully solidified and the bottom is only in 3 segments. Sainese's intestines have undergone changes, with both the small and large intestine now being longer. Sanes has venom. Similar to Debilis venom, the venom comes from a specialized tooth.
The very front top tooth can be stabbed into prey and injects the venom. This venom contains a toxin that affects the victim's awareness and stability, making them more unresponsive to other animals of any species and throws off their sense of balance, basically leaving them trapped in a trance-like state into nothing for about 4 to 6 minutes, depending on the amount of venom and the size of the animal. The second generation is made up of Ovum Raptor, Spina Sculptor, Planus Dens, and Animus Conlabifio. Ovum Raptor. Ovum Raptor, or Ovoraptor, is a bit smaller than Retrato and has more subtle spots on it rather than Retrato's back pattern. These are to help in reaching into nests and eating, or at least stealing, an egg. And luckily for Ovoraptor, almost all animals from Tranifera to Chimexura to Cellura and almost everything else, they all lay eggs. And even better, a lot of them are blind. The only exceptions are immature descendants, Sylvosis lingua descendants, and non-walking radiolis descendants, as well as Rubinus and Admus Fictor descendants, except for Anthrophagus Fictor. All of these don't lay eggs. To help with cracking the eggs, Ovoraptor has blunt teeth. To make sure that the yolk and developing young end up in its mouth, it tilts its head up and gets the egg as low as it can down its jaws, which is usually just above these teeth, and then crack the egg. If it's found napping eggs, or more often in the open wandering, 3 things help get Ovoraptor out of trouble. One being loud, deep, guttural croaks that easily intimidate younger or less experienced predators. Another tailored to those who can see is the many more connected large ribs. Ovoraptor can stand on its tail, and the ribs make the animal appear much bigger than it actually is and more threatening, typically while making its deep guttural croaks. If they get attacked, Ovoraptor can't really do much damage with its relatively weak bite and dull teeth, so it will attempt to turn around and have its tail bit where it can detach and keep wriggling.
While Ovoraptor gets to escape, the predator, or angry parent, gets a meal, or just a sense of satisfaction. This tail, though, can't grow back, and it simply scars over. Ovoraptor, thanks to its larger ribs, can move faster and has special muscles to move the ribs and drag themselves along. Spina Sculptor. Sculptor is smaller than before, but its jaw, in comparison to its body, is bigger. Sculptor is now a bit smarter than before, mostly because it's still a predator but not particularly big, so it needs the ability to better calculate whether a target is safe or not. Sculptor primarily eats Sesolto-Parasiti descendants, particularly those who leech off larger animals, but will eat anything deemed not too risky. Sculptor also has webbed ribs and can use these to glide quite short distances. It can also climb much better with its ribs and the underside of its body having extra grippy skin. The ends of its ribs even end in a few tiny keratin hooks. To help perceive its environment, Sculptor has on the end of its jaws 2 finger-like structures. The top one has the jawbone extend into it, basically making it just the end of the jaw. The bottom is just muscle. These help feel what is in front of it and are extra sensitive to heat. Sculptor also has a very primitive sense of echolocation. Although it works and allows Sculptor to see things decently, Sculptor, to make room for better jaw muscles, a trade-off was made with the larynx and vocal cord size, making both smaller. So Sculptor entirely relies on other animals to get its echolocation to work. Sculptor really prefers to spend its time on Titanus maximus. They provide plenty of noise, plenty of protection, are easy to stick to, and have parasites to eat. Parasites that Sculptor eats by biting it from the sides, dividing the head from the rest of the body, and often swallowing the prey whole. Mating for Sculptor has changed a bit because they can't make much noise. Once in a while, a group of Sculptors will convene together and begin to choose who to mate with, picking bigger and stronger individuals. Once that's done, the duo begin to find a good place to build a nest. These nests are partially underground, and one Sculptor will begin to dig the burrow section, while the other will go find plants and use its finger-like structures to take strips off of those plants. It'll use these strips along with sometimes mud to build the top part, which insulates the nests and keeps rain from getting in. Larger parts of the plant will be carried to the building site and can be used as supports or a foundation. After building a nest, the two will mate, and immediately this presents a problem. Arasibuka and its other descendants use mating calls to find a mate, easily discerning from male to female. But Sculptor, again, can't make these calls due to its muscle trade-off, and doesn't have any obvious differences between the two. And only after the nest is built, after likely days of building, do they truly find out who the gender is of who they chose. Most of the time, all is well. About 76% of the time, it's a male and female. But if either two males or two females have chosen each other, only now do they realize they won't have any eggs. Despite this, most of the time these relationships will still stay in their nest and stick together for a week or so after building the nest. Two vertebrae have large spines that stick out of the skin, and if Sculptor is attacked, it will curl up its tail behind them and will raise its head and open its mouth, letting out whatever gasping and wheezing noises it can. Planus dens. Planus dens, or Delanus, has its top row of teeth completely flattened and can use them to grind pieces of food into softer, easier to swallow, and digestible pieces. The tooth for venom injection is bigger and is actually used as more of a horn than it is a stinger. Over half the time, Delanus won't inject what it stabbed with venom. Although now that it has evolved with debilis venenum, it has more or less evolved around killing each other, thanks to filling a similar niche. But as it happened, Duplex maxilla would also become an ambush hunter, and without the vision of Venenum Fox, or the size and power of Duplex maxilla, Delanus would go extinct if not for two food items. The walking descendants of radiolis, due to their shells and small size, don't get hunted often, but with its flattened teeth, Delanus can crush these animals and swallow the crushed chunks, as well as smaller fisters like Ludius and Caerulum fister, and juvenile Anthrophagus fister. Delanus survives with these food sources, being a rare species, but still surviving. Animus conlabifio. Animus conlabifio, or conlanabifio, is no longer primarily an ambush predator, and is instead a scavenger, and may be an ambush predator on a good day. Conlanabifio's jaws are solid and provide a stronger bite. But instead of biting hard, it uses its many smaller teeth to saw through flesh and bone using neck movements. Speaking of teeth, the venom tooth is bigger and has an orange top to help camouflage. Another tooth has moved forward and has shrunk. This tooth is a neat case of a genetic deformity getting passed down to the generations. Only about 12% don't have this mutation. On the underside of its lower jaw, a bright green display is folded and can be fanned to help cool down if need be, or to scare those who threaten Conlanabifio. And Conlanabifio can tell if something can see with its own small eyes. These eyes can only see green and the vision itself is poor. They can't see much more than 30 micrometers in front of them. But when it was completely blind before, this is a massive upgrade. The venom of Conlanabifio has been improved significantly and is what gives its name Mind Melter. Before, and the venom of Delanus, the venom would throw off an animal's sense of balance and cause them to become more unresponsive and in a trance-like state, almost like they're stuck daydreaming. And while the venom still only throws off the balance enough to slow them down to make them easier to take down, now the venom in lighter doses causes visual, auditory, and smell hallucinations, but in bigger doses, done on more bigger, meatier prey, or more threatening foes, borderline hyperactive delirium. To prey who can't see, it's mostly consisted of horrifying noises, vile smells, and even sudden pains and aches, making them think they really are being killed. To those who can see, the hallucinations can cause heart attacks, aneurysms, seizures, and death. The venom also lasts longer. Instead of the 4 to 6 minutes of dizziness and tiredness, it's 24 to 28 minutes of hallucinations and mood swings. The venom also doesn't immediately activate, only till it gets to the brain, so usually about 2 minutes later it starts. But usually hallucinations and overall effectiveness wears off slowly after the first 7 to 8 minutes. The venom does have a major problem, not just that it's extremely expensive to make, but also that an animal's direct intelligence, experiences, and confidence directly impacts the reaction from the hallucinations and even what the hallucinations are. Giant animals don't have much of a reaction due to their lack of predators, high confidence, and the fact that they simply need more venom to have an equal reaction. But those who are of more equal weight class or smaller than Conlana beefio, i.e. animals with more to fear and more experiences with dangerous situations, tends to have a much more violent reaction. But also smaller, less intelligent animals like Cava Facies don't have a big reaction either. Conlana beefio is the dominant species. The next species descendants are from the apex predator Cava chaser, who split into Labellum chaser and Seta chaser. Labellum chaser. Labellum continues to improve its bite force, but in doing so faces a durability problem, but not with its jaws. When Cava chaser and its descendants bite, the two mandibles move up and convene together and hit the gray sensor or whatever is in between. But if Labellum really wants to, it can shatter the sensor's exterior and leave it to dry up, causing a dampening of its senses and pain, similar to dry socket. To help prevent this, a lip-like structure absorbs some of the force of a bite, helping dampen the damage. And plus, the lip is quite far back and doesn't really cause problems when biting prey. Speaking of the gray sensor, Labellum's is split on the end and has improved senses. Labellum is bigger and has no problem eating an already dead animal. Seta chaser. Seta chaser is almost exclusively a scavenger. Seta's jaw is better for sawing through meat, Seta even having a weaker bite. Seta is a bit smaller than Cava chaser. Seta's gray sensor is now far stronger, but at the cost of many segments, and now Seta has a poor sense of smell and an almost non-existent sense of hearing. Although this does affect their survivability, it's not what made them go extinct. It was the abundance of other scavengers already doing their work, and as such, Seta just didn't make the cut. The second generation is only made up of Fossibus rex. Fossibus rex, or Rosidex, is the single largest predatory species in the cup. Rosidex's gray sensor is not only further split, but also starts its usual pale gray and fades to an almost black. It's also made up of many more segments, but is thinner to shed weight. The biggest thing Rosidex evolved was a pair of upper jaws. These jaws also have the extra bones inside to improve bite force, giving Rosidex the strongest bite force by far, and it doesn't have to worry about busting its gray sensor. The extra bit on its arms runs all the way up the lower arm, enhancing speed. Rosidex has a better sense of smell and hearing. Rosidex's arm is extra strong and makes Rosidex much faster. Rosidex, to feed its massive, muscly body, will eat anything of decent size, dead or alive. Fully grown adults can even kill Titanic Maximus, usually after a few attempts though, and that's not to say it can't lose. But with Rosidex being as much of a muscle beast as it is, many animals, when they have the opportunity, will kill and eat one. The only time you can is when they are babies or juveniles. Although parents do their best to protect their babies, with Rosidex being so big and the babies being so small, smaller predators actually have an easier time killing the babies than something like Duplex maxilla, since a smaller predator can hide easier. The only two species that get a chance of getting away with attacking an adult even kind of scot-free is Titanic Maximus and the second largest predator of the cup, female Caverna rex. These two don't get into fights often due to the many steps it takes for an adult female Caverna to leave her cave, and then these two have to meet in the same place at the same time. But with the two being hyper-aggressive, if all the pieces do go together, they almost will fight. With these fights, it's actually quite even who wins. Despite being smaller and not as strong as Rosidex, C-Rex with her giant blades can theoretically somewhat easily kill Rosidex. But who wins is mostly a matter of who gets the first good hit. If C-Rex gets a good stab to the stomach, then it's up for Rosidex. If Rosidex gets to the spine or bites an arm off, then it's up for C-Rex. Rosidex adults are often covered in small faded scars from hunting animals like Demutador or Doplex maxilla. The second to last species descendants are from Interfector Collis. The first generation is made up of Pollens Collis, Interfector altus, Pagna membrana, and Gigans radix. Pollens Collis. Pollens Collis, or Pollens, has cut the cost of making chlorophyll by having less chlorophyll, making it paler. This means that Pollens will have to rely entirely on its membrane to catch more food. Despite this need, Pollens is smaller and has a portion of its membrane missing. Pollens is a tundra dweller, but only in the very lower portions of the tundra. This poor example of evolution, along with Pena army descendants getting bigger, has led to Pollens' extinction. Interfector altus. Interfector altus, or Alterfectus, is taller than Interfector. Alterfectus has a significantly smaller leaf. The membrane is only on the middle and higher portions of the stem, which has a higher success rate than before. The membrane is also thicker, making digestion slower, but the membrane itself is now able to handle the now bigger Pena army bodies. Pagna membrana. Pagna membrana, or Pabrana, has a much shorter leaf than Interfector. The membrane of Pabrana is a lot bigger, starting just above the ground, but is far worse at digesting material in general. But instead it now has a low amount of photogears and photosynthesizes. This membrane can also absorb water from the air. Pabrana is taller than Interfector, and has a bigger root system. Gigans radix. Gigans radix, or Ragandix, is overall bigger than Interfector, but Ragandix has especially large roots. Ragandix has less of a membrane and relies more on photosynthesis. The second generation is made up of Palus faestula, Pulvis captionum, Palus agricola, Humus bestia devourador, and Humus bestia nidum. Palus faestula. Faestula is taller than previously. Faestula is only found within the swamps. Faestula is significantly more reliant on catching food, having no leaf. But they do have a darker stem, letting them last longer between meals. Faestula walks the line between threatened and endangered, primarily thanks to most catchable flying animals preferring wider open areas, different habitats, or vastly different kinds of forests. Faestula's population usually goes back and forth between 4,000 and 6,000 individuals a year, occasionally having a spike if prey is abundant, or dipping if prey gets sparse. Faestula almost entirely survives off of natatorius column, their populations in local areas more or less being connected. Pulvis captionum. Pulvis captionum, or captipovum, is arguably the most unique of these descendants. The membrane of captipovum is oddly shaped and thinner, but this membrane not only can still absorb water from the surrounding air, but can also collect and digest airborne dust, making Captipovum a silent competitor of Fisturidae. This simple adaptation not only allows Captipovum to grow bigger and have a stronger body, but also to grow in a much more diverse group of locations. Instead of just the typical steppe and swamp, Captipovum grows in the steppe, swamp, savanna, and absolute lowest parts of the tundra. Palus agricola. Agricola is taller than before, being the tallest of these descendants. Agricola's leaf is taller. Agricola's membrane reaches all the way down its body, and is packed full of photogears. Agricola, being as big as it is, often finds itself as an obstacle for moving soda and animals, and often Agricola's membrane gets ripped and torn, and for this, Agricola can regenerate its membrane.
Agricola can no longer capture food and relies entirely on photosynthesis. Humus Bestia devourador. Humus Bestia devourador, or Humistidor, has no membrane and a slightly darker stem. Humistidor is toxic in a unique way. Humistidor has 7 times more alcohol in its system than any other plant. And eating Humistidor can easily make any small or medium-sized animal drunk, which can lead to over a dozen problems, including death. To help out the blind, you can smell the alcohol off of Humistidor. Humistidor's big evolution is that although it can photosynthesize more, it can still catch food, but instead of flying animals, Humistidor hunts those who dig underground, mostly being Cava Facies and Sanguinalis. And while the poison of Sanguinalis is beyond horrific for animals, to plants is completely ineffective, so Humistidor has no problem digesting Sanguinalis. To catch these critters, Humistidor has a very fine velcro that can effortlessly cut into the skin of these two and get them stuck. And when they get stuck, the roots will slowly wrap around the animal, and digestive juices get released down onto the creatures and then sucked back up by the roots, slowly and painfully killing the animal. Luckily for Humistidor, these animals have relatively poor vision. You can't smell the alcohol underground very well. So both animals struggle to detect if they're about to run into Humistidor. Sanguinalis, with its great sense of smell though, is more likely to detect Humistidor. The best chance Cava Facies has of recognizing the consistent size and shape of the roots, but that takes a lot of intelligence that Durham simply doesn't have. Humus Bestia nidum. Humus Bestia nidum, or Humistidum, is a bit smaller and has no membrane. The stem of Humistidum is far darker, now running entirely on photosynthesis. Like its cousin, Humistidum has specialized roots for the subterranean, but instead of killing them, these roots are hollow and have an opening on the bottom. This chamber is pumped full of oxygen, and animals can lay eggs in this root to remain protected from outside threats, on top of these ledges. The final descendants of not just this episode, but of the 60s Cup are from the wonderfully unique Lada Otis, whose first generation is made up of Aqua Dispator, Clara Fee, Capitosis Otis, and Cava Facies. Aqua Dispator. Dispator has bigger fins than Lada Otis. Dispator is semi-aquatic, and along with the fins to help with movement in the soda, the hands have split. But these are not flexible like the rest of the arms. These fingers are made from the final segment of the hand, and it simply extends into this new form. Between these two is a thin webbing to displace more soda while swimming. While under the soda, Dispator can't hear nearly as well, nor can it smell really at all, relying heavily on its vision. Dispator is more herbivorous, but still gets its meat in when the opportunity presents itself. Clara Fee. Fee has longer arms than Otis, and its hands go so far up its arm that it looks like it has a second elbow. Unlike Otis's simple hand, Fee has rounded hands, the bones being bigger, and at the end, the final bone segment protrudes through the skin and can be used as a weapon. The males of this species have bigger, brightly colored bottom fins. These are both used for communication as well as a mating display. If it's not mating season, these fins are usually just red, but if a male is being angered by something or has interest in something, this fin is flushed with blood and gains its colors. Capitosis otis. Capitosis otis, or odiosis, has a bigger head containing a bigger brain. This brain is capable of more complex things to help with Odiosis's not only wider range of environments, but also its far more nomadic lifestyle, traveling the equivalent of miles every day. Odiosis has 3 small fingers who are actually flexible. To prevent issues when grabbing things, the sensory hairs on Odiosis have moved further up the arm. Odiotis's teeth are better suited for more general eating habits. Cava Facies. Cava Facies, or Cavacies, is the most unique of this generation. They are much smaller than Otis and have an orange and brown skin color to camouflage among the foliage.
Like Cava Facies have the final hand segment protrude from its skin in a much sharper point though. Cava Facies' fins are more specialized. The bottom fin is not even present. The side fins are and help Cava Facies move. Cava Facies no longer floats and instead slithers on the ground. The top fin is usually folded, but when agitated it flips up in an attempt to intimidate a target. Cava Facies' mouth is very much longer towards the top end for a reason. Cava Facies primarily hunts Durum facies, only occasionally supplementing their diet when needed. While Durum facies stay in their tunnels most of the time, but at night they come to the surface to find bigger, more nutritious food items. Cava Facies will place its mouth at the entrance to a burrow and wait till Durum facies thinks it's night and attempts to leave, where Cava Facies will quickly pull back its mouth and stab into Durum facies and kill it. Luckily, Durum doesn't have very fast reflexes, so it's not too difficult. This hunting method also prevents Cava Facies from eating Sanguinalis, since it has to look at what it's trying to kill. And also the two are of similar size. Cava Facies are more antisocial than Latiotus, preferring to be alone unless it's mating season or it's protecting eggs. Cava Facies doesn't get food as often as Latiotus did, and as a compensation it is more cold-blooded, being on the warmer side of mesotherm. The second generation is made up of Gigans natator, Latius bestiaris, and Tumidus cerebrum. Gigans natator. Gigans natator, or gigantator, has massive fins further supporting it in the soda. The fingers have spread further. The sensory hairs on gigantator work better under the soda, being able to hear pretty well, and being able to smell at all, although poorly. Gigantator is bigger than before. Despite the many aquatic adaptations, Gigantator still spends some time on land, mostly to find extra food and avoid predation. Although the sodas are filled with Carnoradix descendants, the roots that make up most of the body are hard to digest, and Gigantator is just not suited to eat them. Gigantator, despite its now larger size, is still a prey item for animals like Nintantus crocodilius or Oases facies, just a more risky prey item due to its size. Gigantator eats mostly the reachable leaves of Carnoradix descendants, Rosea hyder, and occasionally eating bigger items like Nintantus huverus or Cyclopsis. If times get tough, Gigantator will move to land and search for fruits, dying animals, or alone eggs and babies. And because of the rather easily huntable nature of Gigantator, it's less common than other non-carnivorous aquatic animals, and it more populates bodies of soda inhabited by Mura repleti shredder or Prey grandis, two species who don't really attack them too often and can prevent actual threats. Latius bestiarius. Bestiarius is a very sexually dimorphic species. The females have tiny fins but also have the colored bottom fin, being used entirely to convey agitation or intrigue. Females are a bit smaller than the males. The females are mostly herbivorous, occasionally eating a small animal. The females also have a unique red spot on their hands. The males, on the other hand, have no red spot. The side and top fins are only a little bit smaller than previously, but the bottom fin is massive, and when the moment calls for it, it has a pink, orangish, and purple spots. The males are more carnivorous than the females, using their claws to hunt prey. This species as a whole is smaller than previously. Tumidus cerebrum. Tumidus cerebrum, or Tuceridus, has an even bigger brain, and it's more neuron-packed and dense, making Tuceridus even smarter. Tuceridus is more actively social, hanging out in bigger groups. Tuceridus has generally reduced the amount of fighting that occurs between individuals. Tuceridus also now has much bigger social circles, and along with the usual romantic partnership, they have friendships. These friendships are usually between individuals of a similar size, same sex, and who see each other often, though this is a very general trend. On the more physical difference side, Tuceridus has less fins, having 2 of the 4 side fins gone. The rest are a little bit smaller. Tuceridus has a round eye with no visible segmentation,
This is thanks to an outer fleshy layer more similar to our eyes covering the initial harder eye. This new fleshy layer improves overall vision, also improving vision in the new color receptors, allowing Tuceridus to see all the colors that you and I can see. The fingers of Tuceridus are made up of less segments, only 3. This, although makes them less flexible, they are stronger now. The fingers are also much longer. And the third generation, the final generation of the 60s cup, is only made up of one species, the Conquistador Scientia. Conquistador's outer eye layer now has a pupil, coming in a variety of colors. The hard parts are still there and actually improve Conquistador's night vision and help prevent blindness from eye damage. The sensory hairs are not only better at hearing and smelling, but also have moved further up the arm. Conquistador has remarkably large brains capable of the most complex actions of any species, and this reaches its peak at the evolution of not sentience, but sapience. Though what is truly considered the separation with sentience and sapience is rough to say the least, and many others could qualify. But this sapience essentially allows Conquistador to go anywhere as they please, and with technological advancements, do as they please. And while I won't go into the specifics of their society, religion, and more specific topics in this video, I will broadly go into the topic using us humans as a basis for what is different and what they are better or worse at. Conquistador, evolving from a species who is not only quite friendly to each other, but also evolved from a predatory species who did not receive much pressure from other predators, and did not have much selective pressure for getting a mate, are generally far more open-minded, social, and overall nicer to each other than we tend to be to each other. Equivalent groups who tend to be suppressed or discriminated against in our world are nothing more than another thing in this one. Conquistador uses vocalizations to communicate, obviously not speaking any language found in our world. In fact, Conquistador would struggle to speak English, for example. They would use plenty of S's, H's, and TH's due to their lack of lips, basically sounding like they have a lisp. They use their fins for displaying emotions. Fins slightly pointed upwards are indifferent, raised fins are excited, surprised, and or happy. Completely flat fins are a sign of shock and or general nervousness, anger, or disappointment. Lowered fins are sad and or sick. Although most of the time, in general conversations, these fins are indifferent and simply sway as the tail moves. In their society, countries aren't the exact same as our equivalent. Areas are more or less separated as a way to more easily locate some town or city, or explain where something happened. Lands are separated on maps, typically separated by rivers, lakes, and mountains. Conquistadors are very caring for the environment around them and try to use non-lethal ways of removing a problem, like extremely loud bells to drive off most blind animals, but many species have the capacity to kill a conquistador, either in self-defense or actively hunting them as prey. And when needed, lethal force is used. But do not mistake Conquistador for being perfect. A video going in depth on Conquistador society will be made, clarifying, describing, and showing many different but important facts about this wonderful species. And that marks the end of this episode on the speculative biology inside a McDonald's cup. But it's far from over yet. There's still one huge factor not yet talked about that opens its own can of worms, or should I say cup of worms.